Alright, welcome back everybody. In this video we're continuing with section 10.2 of AP Calculus BC, working with geometric series. We're going to pick up right where we left off here with example D. In this example we're determining if the series converges or diverges, and then if it converges we're finding its sum. So looking at this series and thinking about what's going on, this is the sum from 1 to infinity of 16 over n times the quantity 3/2 to the n minus 1. So the first term, if I substitute 1 in here for n, that makes this 3/2 to the 0, which makes our first term 16 over 9. And then every time we cycle through n in our summation, when we make n 2, then we've got 3/2 to the first power being multiplied by 16 over 9. When we make n 3, then we've got to the second power. So we're consistently multiplying by 3/2 when we do this. And so let's see, 3/2 times 16 over 9, that's going to be 48 over 18, which is 24 over 9, which is 8 over 3. And so there's what our geometric series is. We can identify the terms here. You know, A is equal to 16 over 9, R is equal to 3/2, but R being 3/2, that means that the absolute value of 3/2 is greater than 1, which tells us that this series diverges. All right. Part E, this one's a little tricky maybe, because when n equals 1, that's going to be our first term. So don't just fall into the habit of thinking that when we see one of these in summation form that this is always going to be our first term. That's not the case. Looking at this, when n is 1, that's our first term, and that's negative 1/4 to the first power. So we've got to multiply, and we find that the first term of this series is negative 7 over 24, and then would be plus 7 over 96, etc., etc. And so our A value here is negative 7 over 24, and our R value is negative 1/4. The absolute value of negative 1/4 is less than 1, which means that this series converges. And then we can find the sum by setting up A over 1 minus R. So that's going to be negative 7 over 24, all over 1 minus negative 1/4. It's negative 7 over 24 over 5/4, which is negative 7 over 24 times 4/5. Let's see, it gives me negative 7 over 30 as the sum of this convergent geometric series. All right, let's look at the next one. F is the sum from 0 to infinity of negative 6 times the quantity negative 1/2 to the n plus 1 power. Okay, so let's see, when n is 0, that means this is negative 1/2 to the first, and so the first term of this series is going to be 3, and then minus 3/2, etc. So A is equal to 3, R is equal to negative 1/2. The absolute value of R is less than 1, so this converges. And then I can use the sum formula to find what it converges to. The sum is equal to A over 1 minus R. So that's 3 over 3/2, which means that this is all going to add up to 2. All right, that's how we can determine if a geometric series converges, and then if it does converge, what its sum is going to be. All right, let's look at example 2. For what value of R does the infinite series sum from 0 to infinity of 8 times R to the n power equal 13? So, first of all, we're trying to determine what value of R makes this equal 13. That tells us right away that R has to be in between negative 1 and 1, because that's the only way that this series converges, which is the only way that the sum can be equal to a particular value. So we know R is between negative 1 and 1. Let's go ahead and figure out what this series looks like. When n equals 0, this is 8 times 1. So the first term of the series is 8. When n is 1, this is 8r squared, etc., etc. So for this series, a is equal to 8, and r is just equal to the r value that we're trying to find. That's going to be what we solve for in this case. Now we're told that the sum is 13, so that means s is equal to 13. And then we're going to go ahead and just set this up as sum is equal to a over 1 minus r. So we've got 13 is equal to 8 over 1 minus r. And we can go ahead and solve this equation in order to find the value of r. We'll multiply both sides by the quantity 1 minus r. We'll distribute. Subtract 13 from both sides, and divide both sides by negative 13. We end up finding that the value of r is going to be 5/13. All right, and one last example for this lesson. If f of x is the sum from 2 to infinity of the quantity cosine squared of x over 4, all that raised to the n, then f of n is equal to what? So first of all, since this represents the function f of n is going to be what I get when I substitute n in here in place of x. So f of n is going to be this series, the sum from n equals 2 to infinity of the quantity cosine squared of 9/4 raised to the n power. Now imagine what this series looks like, because we're cycling through our n values from 2 to infinity. So that means that the first term of this is going to be the quantity cosine squared of 9/4 raised to the second, and the next term is going to be cosine squared of 9/4 raised to the third. We're cycling through those n values, cosine squared of 9/4 to the fourth, etc., etc. And so for this series, that tells us that a is equal to the first term, cosine squared of 9/4, quantity squared, and r is the common ratio that we're multiplying to get from one term to the next. And that's going to be cosine squared of 9/4. Right now, confirm. In order for this to converge, cosine squared of 9/4 has to be between -1 and 1. This is not hard for us to confirm. We know that cosine has to be between -1 and 1 inclusive. So unless what's inside the cosine function makes it 1, when we square it, this value is going to be in between 0 and 1. And this is going to converge. Just in case you're nervous about that, you can pretty easily confirm. Just find the value of cosine of 9/4, quantity squared. Oh, I missed a parenthesis. Actually, I had one too many parentheses. All right, and that's between -1 and 1. So this is going to converge. And now I can find the sum. The sum is going to be equal to a over 1 minus r. And now I'm just going to go ahead and use my calculator in order to find the value of that. So this is going to be cosine of 9/4, quantity squared, over quantity 1 minus cosine of 9/4, quantity squared. And we end up finding that the value of this sum is going to be 0.257. All right, that takes us to the end of this video and the end of this lesson. Those of you who are in my class, go ahead, do the practice problems, and then at the end there should be an assignment on my AP for you to complete to check your understanding on the concepts from this section. We're going to go ahead and come back in the next video where we will introduce you to the nth term test for divergence. See you then. Have a great rest of your day, everybody. Bye-bye now.